I love numbers, but it's hard to read them. It's not easy to get information. And this is where we can use our visual cortex, right, and our human brain to be able to pull this information out. And so this is what we're going to look at now. So the first thing is that we can see changes over time. Kind of pops up. All right. So next thing I'm going to show is like another pattern or another data set. In this case, the New York Stock Exchange. It's on a monthly case. And you'll see here when I load this in, just to kind of look ahead, is we just have essentially this month. And then in this case, I believe, is this the whole data set? I just want to make sure. This column name, date time. Yeah. So basically this data set only has what month and then the monthly return. So you can see here again, I just did the same kind of stuff where I made sure this date time in this case is actually this part right here, and making sure the index itself is going to be this column right here. Okay, so again, just making sure like, oh, this is date time, and also we're treating that as the index. Okay, so nothing important or nothing new from what we just saw. So the next part is like we can visualize this, say, hey, okay, now that we have this as the index, we can just simply say, all right, go ahead and plot this information. In this case, it's just a line plot. So basically, it'll connect each point in time with a line. So you can see here, this is what you probably traditionally see, like if you imagine the stock market or any kind of like time series stuff, usually you'll see a lot of these kind of line plots, right? And this makes sense too. Hopefully this makes sense, is that usually we connect it with the line because it makes sense that this one changed to this part and this part and this part and this part and this part. So they're not just a bunch of random data points like a scatter plot would be. Scatter plot in a lot of ways, it's like each point is not affecting it, but in this case, we're showing that relationship that this one goes to here, here, here. If you ever have done this by accident, if you've taken some like data points that are supposed to be more of a scatter plot than it is like a line plot, if you try to do a line plot on there, you'll see like your data all of a sudden get like going all over the place, and that's because it's not really, the index is being the one that's telling you how do we connect these together, and that's why we set this index to say, oh, time is the important part. We want to connect these parts together so we can show that time progresses forward. Okay, cool. So this is probably one of the most common ways you'll see time series data represented. Okay, another part you could do is like a dots plot, and basically it's the same thing as the line plot, but instead you don't connect the dots. And so this case, this is probably not the best use case in this case, but sometimes it might make sense to actually do more a scatter plot looking kind of thing, where maybe you have a very clear pattern. If we see a very clear part, maybe it's just fine to just do a dot plot. But in general, you'll probably use a line plot more often for time series because you want to see that connection between different data points. Okay. Any questions so far? Pretty straightforward, hopefully. Cool. All right. So kind of moving forward then. So again, you see, I'm already answering. I need to pay more attention to like what I'm going to say. But question between dot versus line plots, just know that there's a difference because we want those things to show that there is a connection between each point. Sometimes it might make sense if we have multiple data sets. Maybe it makes sense to see the pattern better with a dot plot. But in general, you probably would want a line plot. Okay.
Would you be able to do like an overlaying line plot with the dot plot so this way you're able to see like the interval at which you have the data points?
Yeah, so let's try that real quick. So one thing you can do, you can run this over here, and then hopefully it's just, I don't know, I have to add this on. But yes, you can. I'm not going to go ahead and try to mess around with it, but yeah, you can definitely. And so if you're talking about like, so you have this line plot and you can see each of these dots.
Yeah.
Yeah. So this is something like, to be quite honest, I am not a matplotlib kung fu knees person, like to be able to do this really well. My matplot fu it is not strong. So this is something that you can do. I just not as comfortable, if that makes sense.
Yeah.
All right. And we'll actually see this a little bit in grouping plots where it's not exactly what you're asking, Lucy, but kind of similar to putting multiple line plots on top of each other. You could do dot plots and dot plots and line plots together, but this kind of helps you kind of see this different change. So this is where like we want to look at multiple years. So for example, let's say you want to split up this line plot and say, well, I want to look at 1961 to 1962 by itself. So maybe you want to see how it changes throughout the summer or throughout the winter. And then basically you say, oh, I also want to see 1962 to 1963 and see those plots going forward. In the stock market, it might not be super obvious in that way, but this could be really important for climate data. For example, our Earth has seasons. So you would expect to have a similar patterns going through each part of the season. And we'll see something like that in a second, okay? So here is one from the curriculum, and this is taking the New York Stock Exchange data, and we're basically just going to separate it by year groups, okay? So in this case, this frequency A, it's just annual. So this is basically saying, all right, we're gonna annually take from January to December of each year and group them together. So essentially, we're making new little data sets from 1961 to 1962, 1962, 1963, and so on, all right? So now we can go ahead and run this, and we can see now is that this is some nice little plot. This is directly from the curriculum, just to let you guys know. But you can see here is that you can have all the data points now. This is just 1961's data, 1962, 63, and so on. And you can see here this 0 through week 12 is the different months. So you can kind of hopefully, this can help give you a comparison of saying, okay, maybe, for example, I'm just gonna make something up, the stock market has changed. It starts off really high, and then as the year progresses, maybe it goes lower and lower and lower. And then when, I don't know, the end of December happens, it shoots back up. Like you could start seeing that pattern. Now, I don't know about you guys, when I look at this stuff, I'm kind of like, I can't really see a direct pattern, but it's not super clear to me. And this is where, for example, like, well, this might be really tough for us to see individual. It might be certain circumstances where we want to see a progression. So for example, maybe there's a very clear pattern, but one thing we could do is just plot them all together. So in this case, instead of having subplots equal true, we simply just set it equal to false here. And this will say, okay, put them all together. And you can see here, now we have all our data points on here. In this case, maybe there's a pattern, but it's not super obvious, at least not to me, where we have some change in events and stuff like that. So let's see here. I want to see if I could do this stuff for you real quick. No, I'm not going to deal with that. Okay. I was thinking like, what could we just go ahead and do this plot, but you can combine those plots together too, any plots you want. And this is more for matplotlib. If you are really good at that, it can be useful. To be honest, I usually look it up specifically. If I have a very specific thing I want to look at, I'll look it up. Otherwise, I'll just default to the different dot plots and stuff like that I can use. And just know that's a different strength that I have or a different weakness I have. Okay. And that's perfectly fine. It's perfectly fine to look things up. Okay. So the next part is like, okay, we can see all these together. It's like, well, what if we want to find more like the distribution of the values themselves? So again, this kind of plot right here has been much more like, oh, let's see how the connection of the plots together. But maybe, for example, we want to group them together to say, okay, well, how many times has it really gotten really high and stuff like this? And this is where we can actually see the distribution of it. Okay, so again, there's a few reasons why we would do this. We can do this for normality. Basically, if you want to say statistical testing on like the actual distribution of the data itself, I can also check on like raw and transform data. So we can see, hey, like maybe this is something, maybe we shouldn't consider this as a time series. Maybe we need to actually consider this as something that's not time related at all. Okay, so just kind of basic stuff is the histogram. So you can see here is that I can just do a .hist here, and I'll basically group them together by this monthly return on the site, or the monthly return is on the x-axis here. And it's just how many would fall within that bin range. And this is what we've seen before. We've done plenty of these kind of distributions. And of course, you can change the number of bins. So you can see this difference. And again, you can kind of see it's like, well, okay, there seems to be like, if the data is random, for example, you would expect your distribution to be normal around 0, right? And you can kind of see that's roughly normal, not quite. You can see it's a little, got some little weird peaks in here and stuff like this. But this can help you decide like, okay, is it more random? You know, is there tends to be a fluctuation in this direction? So for example, it might be kind of skewed off to the left over here, that we definitely have more of the average closer to 0.02 than it is to 0. So in this case, like, oh, it seems like on average, you know, we're tending to see a higher monthly returns than 0. Like it's not just 0, it's not negative, it's a little bit above, but sometimes it'll be a little less than that. Okay. And then this goes into density functions. So just another way essentially for us to plot this data. So this is a, I'm blanking out right now, kernel density estimation. So remember, this is basically taking our histogram, making it more continuous. And this is also a non-parametric way of displaying our data, right? So a parametric would be like, oh, if we're using Gaussian. So this is kind of like making more of an organic shape. And you can see here, and this comes directly from the curriculum, so you'll be familiar with this part when you see it again. And you can see here, if we do that density estimation, you can definitely see like, oh, it's roughly normal. It seems to be closer to a little bit above on the monthly returns. Okay, so you can kind of see like, if you were basically trying to play the stock market, not looking at any specific times, like, well, monthly returns on average would probably be about 0.02-ish. And you can see there's some distribution here. Okay, and this is much different from actually looking at time series itself. This is more like looking at the points as if they're not temporally related to each other. Okay. Okay, and then we have a box plot, which I think is really a cool one. So one nice thing is that we can actually see, like if you look back on this part, I'm trying to go pull this up. All right, here we go. If you look at this part right here, we can say like, okay, each individual data point, like for the month in January, we can see a fluctuation, but maybe for certain months, I'm trying to find an example real quick. Maybe like closer to like on this, the 9th month right here, it's a little closer, like most of them are right around here and there's some fluctuation. So maybe, for example, I don't know, some month, like, you know, maybe like in July, the fluctuations differ a lot. So there's a huge amount of variation, but in September, maybe they're about the same monthly returns every time. So this is what we can use a box plot for, is actually see this distribution over time. So here we go. So this right here is representing basically from that 1961, 1962, that distribution of the monthly returns for each year. And you can see in 1965, except for a few outliers, our box and whisker plot shows like, well, it's pretty, the distribution is much smaller, really close together versus something like in 1961 where there's a huge variety of different returns. So this could also give you some information. And this, again, isn't necessarily something that we'd have to use for temporal time series data, but can help determine some extra stuff, some interesting features that are not directly about a time series. Okay, cool. So we've seen box plots before. I think it's one of those ones that we tend not to maybe sometimes forget about, but I think box plots and like sometimes called box whiskers, box and whiskers plot, it can be really useful for distribution. An alternative to this would also be like violin plots, which are used in Seaborn, which I think are always really pretty to look at because they got the full distribution of it. But this also gives you basically your average, your inner quartile, so basically 25 to 50% of your data. So 50% of your data is within this box right here, and this shows the full range itself. And then depending on how your settings are, you might also exclude your outliers, which tend to be 2.5 standard deviations, 3 standard deviations, depending on your setting of what counts as an outlier. Okay. So our last one is our heat map. So this one's probably something we don't really see we haven't seen yet, okay? But we can use colors to show patterns within our time data. So I like this one a lot because this kind of shows you a little bit of, is this from? Oh, okay, I just grouped it by year. So what's nice about a heat map is that we can actually use this to see visually with color, you know, changes over it. And again, we're pretty sensitive to actually noticing hue change and stuff like this. So kind of showing a little bit like why you would use a heat map, like when it would be useful. Sorry, I don't know why I have it like this. No, okay. So the first thing we do is say, okay, we could plot each one in a subplot. And you can see here, well, we can get a feel for it. But again, this is where it's like, it's almost too much information at once. It's too separated. It's hard to like group them together to see exactly how things change. Like, at least when I first initially see this, it's like, oh, it looks like it kind of dips down maybe like in the middle here, but then you see the different scales here. It might be a little, you could maybe format this in a little bit better, but for the most part, it's hard to take in all that information. So one thing we could do then is plotting all the lines together, like we kind of showed before. Okay, and you can see here, this is, in this case, what is this one exactly? This is temperature, good. Okay, so this is actually temperature over a year, okay? And so you can see here, it's like, well, okay, now we actually see a dip. And it's like, this is starting to make more sense. We're actually starting to see now a dip in temperature for that year. And depending what the area is and what the scale is from 0 to 365, let's say, for example, you're in the Southern Hemisphere, this, you know, corresponds maybe to like winter in the Southern Hemisphere. So maybe the temperature would go down, you know, at that time. And you can start seeing that pattern where over here, it's not, I mean, at least when I first look at it, it's not super obvious that like it dips down in that area. Like maybe I kind of notice it, like just barely, but it's not really obvious that it's really clear. And you can see here, it's like, okay, cool. The problem is though, when we graph this all together, we're losing information, right? Like we don't get to see every individual point anymore, right? It's kind of tough to actually get a full picture of what each individual year is actually doing. We get the overall trend of each year, but every individual year, it kind of gets lost in the clutter. Okay. Does that make sense to everyone? Cool. And the last one is our actual heat map, which kind of alluded to. And this one, I just think like you just look at it, it just makes sense. And so this is kind of a good compromise, is that basically each one of these rows right there represents a year. And so what's nice about this is like, well, now we have our individual year. You can get, if you wanted to, you could look at every individual year and run it across and see what that pattern is, right? But also as a whole, as that whole brick right there, it's kind of like this guy right here. It's showing that overall change. So in this case, it goes from yellow to blue, blue meaning a smaller value, red meaning a higher value. Okay, and you can see here, like, okay, on the side here, we definitely have it being a lot warmer than towards the middle here, which is what we saw here. But we can also see like maybe some years, for example, had some really hot points right here, which again, looking at this data, I don't know if you could quickly pull this information out, maybe, but it's a little harder to like ascertain. And you can see here, for example, whatever year this represents in this case would be like, oh, this is a pretty hot part in the beginning, but there's some other more milder time periods right here. And you can see here, even in this particular year, it seems like there'd be a little bit of a hotness that's kind of unusual. So you can, again, very quickly pull out information from this graph just by basically using colors as an extra dimension. Okay, cool. And it's plus it's pretty. I don't know about it. Well, I think this is pretty too. It's just a little messy in a different kind of way. Like a Pollock kind of picture. Any questions on anything kind of went through? Pretty good? Thumbs up? Sound good? Okay, cool. And again, these are just different ways you can plot the information. And like I say over and over again, doing a visual plot is so important because, again, our brains are just really attuned to notice these differences. Note also, you can probably very quickly talk to someone and present something like this, and they can get a feel for what this is representing, especially for something like temperature, where you essentially or associate blue with cold and red with hot. So this could be a really useful visualization. Also, just be aware of, if you're ever presenting to people, be very aware of red-green color blindness. Don't use red and green. Basically, they're a bad choice. You could present something like this to show an overall trend. And this is debatable of like how much you'd actually want to care about showing someone. In this case, I would average them together and say, well, let's average each day and maybe present just one big graph versus all this big mess. But this would achieve the same thing of what you're trying to achieve here, but just using colors. Cool. Okay. Again, it's beautiful.